So a linear relationship is called a direct variation. When the ratio of the y coordinate to the x coordinate is constant. And we'll talk about what that means in a bit. That means it stays the same. And the y-intercept is 0. Remember, we talked about y-intercept on Monday? It's where it crosses the y-axis. So these are the two key components. So I'm going to highlight those things. So direct variation is when the ratio of the y coordinate to the x coordinate is constant and the y-intercept is 0. And what we normally say is y varies directly with x. And we're going to have a magic equation for that. And then we'll add to it. We'll spice it up tomorrow. And tomorrow we won't be talking about direct variation. But when we have a direct variation situation, the linear equation is this: y equals mx. Okay? We're going to call it y equals mx. At least I like to call it that. What do you think this m is? You remember what we called m when we were doing the slope formula? Go to the notes for the slope formula for a minute. Just take a moment. So we use the variable m to represent what? Yeah. Yeah, the change in y values over the change in x values. But in general, what is that whole concept called? Slope. So it's the slope. M is the slope. From now on, this year, next year, and probably forever on, we're going to reserve that letter m, that variable m, quite a bit, especially when we're talking about functions, as the rate of change or the slope. Okay. So what's real important here is that direct variation equations are proportional. They always go through the origin. Therefore, the y-intercept will always be 0. And the coordinates, they don't add it here. But the coordinates are always going to be 0, 0. 0 for x and 0 for y. Okay. So first check to see if you have a direct variation or just a linear equation. Most of the time we'll have a linear equation, but it's a little easier when we do have a direct variation. On a graph, just look to see if it does go through the origin. With the points, if you have a table, we want to find the slope. So if you have points or a table, we're going to find the slope and the y-intercept. And we'll cover all that right now. All right. So let's say we do have a direct variation. So now what are we going to do? Well, it depends on what we have. Let's say we have a graph. Let's suppose we have a graph. So if you have a graph, we're going to find the slope. And actually finding the slope when you have a direct variation is a little easier than that slope formula we were doing, but we'll get to that. And then we're going to substitute the slope to find m. So let's say we have some coordinates. If you have the coordinates for x and y. Well, then we're just going to substitute y and x into our equation. And this is our equation. Y equals mx. And then we're just going to solve for m. And then once we find the slope, that m number, we're just going to substitute m into our original equation, y equals mx. And we'll have our slope, or our equation with the slope. And then the last possibility is if we have points on a table, or points and a table. We're going to find that rate that we've been looking at. And that's going to give us our m value. We're going to substitute m into our equation. Y equals mx. So we're just going to practice all of these real quick. Okay. All right, you guys ready? So this is actually what's going to happen in the assignment. In the assignments you're going to have to come up with the equation sometimes, and then sometimes they're going to ask you to find that slope or constant of variation. So let's do it. Let's start with the graph. So if you have a graph, we're going to find the slope and then substitute. All right, so now check this out. How do I know that this is a direct variation situation? Yeah. So what we're going to do here only works if the line goes through 0, 0, the origin, okay? Since it does that, we're allowed to take a few shortcuts. Okay. Well, the first thing is we need to find a point. You could use this point, you could use this point. What do you think? I know what. Let's use the following points. It goes through the origin, so we know it goes through 0, and it looks like it goes through 2, 15. There's another point. Okay? So let's find the rise over run. So you ready? We're going to figure out our rise and our run. What's our rise? Yeah, but is it 3 though? It looks like we're going up by 5 each increment. So that would be 15. And if we go across 2, is that 2 or something else? That's actually 2, yeah. Looks like, because we're measuring amount earned in dollars. And so this is 2. So let's figure out our slope, our change in y over change in x. From now on, I'm just going to call it m, if you don't mind, guys. Okay? So what's our rise over run? 15 over 2. Okay? And we'll leave it that way. Okay, we don't need to make it 7.5 over 1 or anything. We'll just leave it 15 halves. Okay? So now here's what we're going to do next. We want to write the equation. And this is the equation we want to write. Y equals mx. Okay? And we're going to write y equals m, but we know what m is. What's m? X. There you go. Y equals 15 halves times x. That's the direct variation equation. And basically, you give me a time in hours, and I'll tell you the amount earned with that equation. Okay? If I know that it's 40 hours, I'll replace x with 40 and get an answer with that equation. Okay? All right. Let's try the next one. You ready? All right, here we go. Let's find the direct variation here. Okay, we're going to assume there is a direct variation relationship. So these are 2 points. They're on a line, and we're going to assume the line goes through what? 0. It has to go through 0. That's our assumption. Okay, so we'll call this x1 and y1. And x2 and y2. Okay. Now, I'll let you decide. Do you guys want to do this using the slope formula or kind of setting it up as a table? Slope formula, let's do it. Okay, so that would be m equals and we're going to put y2 and y1. So y2 is 6. So let's put a 6 here. And y1 is 9. Then we're going to put x2 at the bottom, -2. And x1 is going to be subtracted, so -3. Now, we have to do that subtraction. What's the numerator? 6 take away 9. -3. And over here, since I do have negatives, I'm going to do keep, change, opposite. Keep, change, opposite, do a little inverse addition. What does that give us? 1. So it's just -3. Okay. All right. So we just got -3. Okay. So now we just have our m, -3. Okay. What's my equation then? Y equals -3x. There you go. Okay. Can I let you in on a little secret? This may help you out here. Remember we assumed this is direct variation? Okay, let's do this. This only works when it's direct variation, by the way. Starting tomorrow, we're going to have to do the whole formula. But when you know it's a direct variation, you know that 0, 0 is part of your information to find the slope. So I better write down only works for direct variation. I'll put dv for direct variation. All you really need is y over x. We don't need to do the subtraction portion. Meaning the following. Look, here's an x and here's a y. So put the y in the numerator. Put the x in the denominator. And what does that equal? -3. Try it with the other one. Put the y in the numerator. Put the x in the denominator. What does that equal? -3. But that only works because it goes through the origin. Okay? So I kind of made you do it the long way to show you that's the way it's normally done, but you could take a few shortcuts when it's a direct variation and just do y divided by x on a direct variation situation. And you get the same answer. Okay? All right. Knowing that, when we have a table, how do we know that it's a direct variation, guys?
The x and y starting point.
Yep. Starting at 0, 0. If 0, 0 is part of your table, or if you can backtrack, count backwards, and see that you have 0, 0, it's direct variation. So if I need the slope, I do need the slope. I'm just going to do y over x. Pick any one. Which pair do you want to use? Sure. So 5 is my y value. 10 is my x value. Reduce that. What's 5/10 reduced? It reduces to 1/2. Divide 5 on each side. So now I can write my equation. Okay, I got my slope, 1/2. Y equals 1/2 x. Okay. Any questions? And all of this works because you know it's a direct variation. All right. Okay. Let's look at the back side now. Anybody still writing any of this? All right. So you will see some questions like this. If y varies directly with x, write a direct variation equation for when y equals 10 and x equals 3. Okay. So the key words here, they let you know that it's a direct variation by saying that. Okay? So here's what we're going to do. We're going to start with our equation. Start with the equation we normally work with, right? And let's plug in the numbers we know, meaning we know y and we know x, and we want to figure out m. Okay? So replace y and x with these numbers. So here we go. That's when they told us to substitute, that's what we're going to do. So instead of y, I'm going to put the number 10 equals m, I don't know, so it's going to stay there. And then m times x, which is 3. I'll put that in parentheses to show it's multiplying. So instead of x and y, I put 3 and 10. So far, so good? Now, I want to solve for m. I want to get m by itself in this very simple equation. What do? It's m times 3. What's divide by 3? A lot of this math that we do boils down to simplifying or solving a very simple equation. So m equals 10/3. Leave it as an improper fraction. So now I have my equation. Now I have my slope, right? I can write my equation. Y equals 10/3 x. There you go. And sometimes they won't use x and y, but it's the same concept. As long as they tell you which is the y value and which is the x value. So here it says the following. If A varies directly with B, so basically they're telling you this takes the place of y, this takes the place of x. You see how we had it before? We can go back and replace those. Okay? So just remember, instead of y, we have A. Instead of x, we have B. So you can even go back and write it this way. And then we'll go back and translate the x's to b's and y's to a's. Okay? So let's put those into our equation. So we have A is 1. So where does that go? Yeah, it's instead of 1, right? We said it's, so 1 equals m times 7. And then we divide by 7. You just have to know how to read it back. So you get 1/7. So m is 1/7. So now let's go back and replace for our equation. We could do it that way. Y equals 1/7 x. But say they wanted the equation in terms of A and B. Go back and replace y with A equals 1/7 B. Okay. Okay. So let's see here. They're doing another one of these. So it says m varies directly with n. How are we doing in time? Okay. Let's just go on to one of these. I want to make sure we have enough time to start work. We're going a little long here. Okay. I'd like to do a few of these application ones because the further you get on the IXL, you're going to get a few questions like these, and we want to make sure to answer them. Jose, would you read where it says words, that paragraph there?
Weight?
Yeah.
The weight y of an object on Titan, one of the Saturn's moons, is proportional to the weight x of the object on Earth. On an object that weighs 105 pounds on Earth will weigh 15 pounds on Titan. Write an equation that represents the situation.
Okay. So they already helped us out a little bit. X is the weight on Earth. And they gave us the weight of something on Earth, right?
105 pounds.
Yeah, which one is it? 105. Would be how much on Titan?
15.
Okay. So basically, this is our direct variation. And we are going to assume y equals mx. Okay. So we have to find M. Okay. So let's plug in our numbers. We're going to replace Y with which number? 15. And then this would be 105. Okay? Yeah. So now we want to write this by dividing 105 on both sides. So then M is going to be 15 105, 15 105ths. We could reduce that though, right? 1/7. Wow, that was quick. Okay. So basically, you take the weight of an object on Earth, and it would be 1/7 of that would be the weight on Titan. Okay. All right. Okay, let's try this one. A car drives 330 miles in 5.5 hours. Assume the distance traveled varies directly with the time traveled. Okay? So this would make, this tells us which one is Y. So miles, is that X or Y? Well, let's see. Assume the distance traveled varies directly with time traveled. The first term, the first thing we're talking about is your Y. And what is the first thing we're talking about? Yeah. So this is Y, guys. That makes this X. Is everything okay back there? Everything okay? Okay. All right. So this is the information. Let's go ahead and write a direct variation equation. I would like you to try that on your own. Let's do it right now. Okay, get the help from your partner. You know what X is, you know what Y is. Okay, so hopefully you got 60. So that means our equation would be the distance equals our rate, which is 60 miles per hour times the number of hours. Okay? So now tackle the last part. How far will you travel in 7 hours? Well,
and then you add that to your Y.
yeah. The distance equals 60 times 70, times 7 rather. Hmm? All right. Um, all right. At this point, I think we should just get to work because we've taken a lot on the notes. I think we've covered enough.